In this video I'm going to look at one example dealing with arcs and chords. And there's a lot of little things that go on in this problem, that's why I really like it, that deal with the theorems that we talked about in arcs and 10.3 arcs and chords. So the first thing we want to look at here is it tells us that segment EF and segment GH are equidistant from the center. I'm going to start with that piece of information right there. Now if they're equidistant from the center, that's talking about the distance to the center, and notice it's telling us that segment PQ and segment PR, those lengths are representing the distance. Well, if that's the case, that means that we have to have a right angle here, because a segment, when you talk about the distance from a segment to a point, it's always that perpendicular distance. So being they're equidistant from the center, I know that segment PQ is going to be congruent to segment PR. Now, if the other thing that I know, if they're equidistant from the center, then I know that those segments are going to be congruent. Well, the other part of this is, if I think about my other theorem, is if a radius, now if I were to take segment PQ and extend it, now it's going to become a radius. So if a radius, remember, is perpendicular to a chord, then it bisects the chord, which is going to tell me that this and this are going to be congruent, and the same thing's going to happen down here. I know I can put single ticks everywhere because remember, segment EF and segment GH are equidistant from the center, which means they're congruent. So if you bisect them, both of the pieces on each segment are going to be congruent as well. Now, continuing on, it tells us that the radius of circle P is 15 centimeters, and the length of segment EF is 24 centimeters, and we need to calculate the length of segment PR. Now I'm going to go back to this radius part. So the radius is 15 centimeters. Now nowhere in this picture is there a radius. I guess you could look from P to Q and then my little blue segment that I put on there, that's 15 centimeters. That's one place to put the radius, but a really beneficial place to put this 15 centimeters, I think, is right here. From P to E, because what just happened there is now I have a right triangle from P to Q to E. That triangle's a right triangle. And I also know the length of segment EF is 24 centimeters. Well, if segment EF is 24, then this part right here is going to have to be 12. And now I see that I have a right triangle there, and I can use the Pythagorean theorem to find the length of segment PQ. Well, once I find the length of segment PQ, I know that that's going to be equal in length to the length of segment PR, because they're congruent as I have marked in my picture. Pythagorean theorem, and we'll have it. So I'm going to go through this, and I know that I'm going to go with my A being 12, so A squared plus B, that's what we don't know, call that my X, squared is going to be equal to C squared, which is 15 in this case. Now I just need to solve my equation, and I will have it. So 12 squared is 144, plus my x squared equal to 15 squared is 225. Subtract the 144 from both sides. We're going to find out that x squared equals 81. Take the square roots. Find out that x equals, remember, when you take the square root in the equation, you're going to get the positive and the negative answer. Being that this is dealing with a length, it doesn't make sense for the negative, so I know that this piece right here is 9, which means this piece is 9, and all I need to do is put my label on there. So to answer my final question, the length of segment PR is going to be 9 centimeters. So this problem, you know, I wouldn't call it too difficult as far as the Pythagorean theorem to get our answer. It's using all those little theorems to be able to use the Pythagorean theorem the correct way. You know, knowing that we have a right angle here, knowing that these distances are equal, knowing that we bisect the segment. All those things add into this problem, and then when it's all done, it's just a matter of using the Pythagorean theorem. So that's going to conclude my one example dealing with all the arcs and chords in circles.